Okay, hello everybody. So today we'll be discussing dynamics and physics 11, friction on a plane. So let's just imagine that we have a plane right here, which is 45 degrees. And we have this block sitting on this plane which weighs 100 kilograms, right? So we want to try to find the acceleration of the block because once it starts from rest, it will keep moving downwards and it will accelerate due to gravity, right? So what we gotta remember is that our coefficient of friction is 0.2, which means when we're finding the force of friction, we'll be taking that into account. We have our normal force, which is always perpendicular to any surface, and it's pushing this way. And we have our force of gravity, which is pushing down on the block. It's right here. But what you gotta remember about problems like these is that you always have to split the force of gravity into two vector components. That is the force of gravity in the y, which is also perpendicular to the surface, and this force of gravity in x, which is pushing the block this way. This force of gravity in x is actually this force of gravity in x, which is pushing the block downwards, right? Now, our force of friction is what opposes the motion, so you'll be pushing the opposite direction of the force of gravity in x. Okay, now that we've established our components, we're gonna set up a basic equation right here. So we know that our basic equation is the force is cause the mass to accelerate, right? The net force caused the mass to accelerate. And to find our net force, we will have to find our Fg and x. We gotta subtract the force of friction from that, and then we will be able to isolate our variable and find the acceleration, right? Okay, well, force of gravity is defined as mass times the gravity, right? Times gravity of Earth, which is 9.81 meters per second squared. And our mass is whatever mass we have. So Fgx would be the mass, so 100 kilograms, times the gravity of Earth, which is the acceleration of gravity, which is 9.81, times the sine of 45, because we are trying to find the Fg and x, and we know that this angle is equal to 45. So this Fgx is the side that's opposite to the angle, so sine, right? So we will be finding the sine of the angle, so sine 45 minus force of friction, which is the coefficient of friction, which is 0.2 for us, times the mass, times the gravity, times the cosine of theta of 45, right? Because our force normal is the Fn, and we are trying to find the angle, and this is the side that's adjacent to the angle, so it will be cosine, right? So mg cosine of 45, right? So now caused the mass to accelerate. Now you see how we have a mass here, here, and here. Well, since we have a common variable um, in each part of our equation, that we can simply cancel out the masses from each of the parts, and we'll get that the gravity times the sine of 45 minus the coefficient of friction times the cosine of 45 caused is just equal to 8, right? So now we can substitute all our variables in, and we'll get 9.81 times sine of 45, which is I'll have to calculate that on a calculator, minus 0.2 times the cosine of 45 will cause the acceleration. So now we just use our calculator and calculate it. And once we calculate everything, we get that the answer is approximately 5.55 meters per second squared. downwards down the slope. So the block accelerates at 5.5 meters per second squared down the slope. And I actually forgot to multiply it by the gravity, which is 9.81 right here. Yep, just gravity over here.